Hi guys, myself Manoj. I'm from Sri Venkateshwara College of Engineering. Today's topic is electronic engine control system and performance terms. This comes under the subject automotive electronics. First, the introduction. Electronic engine control system. An electronic engine control system, also commonly known as engine control unit or engine management system, is a crucial component in modern automotive engines. It plays a pivotal role in optimizing engine performance, improving fuel efficiency, and reducing emissions. Concept and functions of an electronic engine control system. Purpose, components, functions, adaptive learning, onboard diagnostics. This is the diagram of electronic engine control system. As we can see, there are so many parts in this electronic engine control system, such as throttle, ECU, camshaft position, ignition, coolant temperature indicator, crankshaft position, mass airflow, HEGO, EGR, etc. The purpose. The primary purpose of an EECS is to manage various aspects of the internal combustion engine's operation to ensure optimal performance, fuel economy, and emissions control. It constantly monitors and adjusts various parameters such as air fuel mixture, ignition timing, and exhaust gas recirculation to achieve these goals. Components. Sensors. These devices gather data from various parts of the engine and its surroundings. Common sensors include oxygen sensors, mass airflow sensors, coolant temperature sensors, and crankshaft position sensors. Engine control unit. The ECU is the brain of the system. It processes data from sensors, calculates optimal engine parameters, and sends commands to actuators to make necessary adjustments. Actuators. These components respond to the ECU's commands. Common actuators include fuel injectors, throttle position actuators, and ignition coils. Functions. Air fuel ratio control. The EECS adjusts the amount of fuel injected into the engine cylinders based on data from oxygen sensors, ensuring the correct air fuel mixture for combustion. Ignition timing control. It optimizes the timing of spark plug ignition to maximize power and fuel efficiency while minimizing engine knocking. Emission control. The system monitors and controls emissions by managing exhaust gas recirculation, catalytic converter function, and other emissions related systems. Throttle control. The EECS regulates the throttle opening to control engine power and torque as needed by the driver. Idle control. It maintains a stable idle speed when the vehicle is not in motion. Overheating protection. The system can prevent engine damage by managing cooling fans and reducing engine power if the engine temperature becomes too high. Transmission control. In automatic transmissions, the EECS may also control gear shifts and torque converter lockup to optimize performance and fuel economy. Adaptive learning. Many modern EECS are equipped with adaptive learning algorithms. These systems continuously adapt to changes in driving conditions, fuel quality, and engine wear to ensure consistent performance and efficiency. Onboard diagnostics. The EECS includes a built-in diagnostic system known as OBD second in most driven vehicles. It can detect and store fault codes related to engine and emission systems, making it easier for mechanics to diagnose and repair issues. An electronic engine control system is a sophisticated electronic system in modern vehicles that manages various aspects of an internal combustion engine's operation to optimize performance, fuel efficiency, and emissions control. It relies on it relies on sensors and ECU and actuators to continuously monitor and adjust critical engine parameters. This technology has significantly improved the efficiency and emissions control of internal combustion engines while also enhancing overall vehicle performance. Engine performance terms. Engine performance terms are used to describe and measure the efficiency, power output, and overall capabilities of an internal combustion engine. Whether you are talking about a car engine, a motorcycle engine, or even a large industrial engine, these terms are crucial for understanding how well an engine performs. Some key engine performance terms: horsepower, torque, fuel efficiency, RPM, compression ratio, specific fuel consumption, thermal efficiency, brake specific fuel consumption, power to weight ratio, turbocharger, and supercharger. Let us discuss what's the horsepower. Horsepower is a unit of measurement of an engine's power output. It quantifies the rate at which work is done. 1 horsepower is equivalent to 745.7 watts. In the context of vehicles, more horsepower generally means greater acceleration and top speed. Torque. Torque is a measure of engine's rotational force. It's the twisting force that an engine produces and is typically measured in pound-feet or Newton meters. Torque is crucial for tasks like accelerating from a stop or towing heavy loads. Revolutions per minute, or it is also called as RPM. RPM indicates how fast the engine's crankshaft is rotating. It's usually measured in thousands. Engines have a power band, a range of RPM at which they produce the most power. For example, a sports car might have a power band at high RPMs, while a truck may have its lower RPM. Compression ratio. The compression ratio is the ratio of volume in engine's combustion chamber when the piston is at the bottom of its stroke to the volume when the piston is at the top of its stroke. A higher compression ratio typically results in better efficiency and power, but it is also requires higher octane fuel. Fuel efficiency. This measures how efficiently an engine converts fuel into usable energy. It's often expressed in miles per gallon for vehicles. Higher fuel efficiency means the engine can travel further on a given amount of fuel. Specific fuel consumption. Specific fuel consumption is a measure of engine's fuel efficiency in terms of fuel consumption per unit of power output. It's often expressed in units like pounds of fuel per hour per horsepower. Lower specific fuel consumption value indicates better fuel efficiency. Thermal efficiency. This term measures how effectively an engine converts heat from burning fuel into mechanical work. It's expressed as a percentage with which values indicating more efficient engines. Brake specific fuel consumption. Brake specific fuel consumption is similar to specific fuel consumption but is specifically used in the context of an engine under load. It's a measure of fuel consumption per unit of power produced, taking into account the engine's efficiency at various load levels. Power to weight ratio. This ratio compares the engine's power output to the weight of the vehicle or objects it's powering. A higher power to weight ratio generally results in better acceleration and performance. Turbocharger and supercharger. These are devices that increases an engine's air intake, allowing it to burn more fuel and produce more power. They are often used to improve engine performance, especially in high performance vehicles. These engine performance terms helps engineers, mechanics and consumers evaluate and compare the capabilities of different engines. Understanding these terms can also assist in making informed decisions when buying a vehicle or optimizing an engine for specific applications. Thank you.